Hi, everyone. Welcome back to another episode of ContextOps. Today, I have with me my co-host, Joshua Thomas, and our guest today is Giuseppe Futia.
Hello,
Hi, Giuseppe.
everyone.
Hi. Thank you for joining us for this episode of ContextOps. Really excited about this conversation. Right. Josh, quick side note, quick background for you. Giuseppe's name was actually recommended by another speaker that we had reached out to for the episode. So that's why we reached out, and he was kind enough to join us on the show. So I'm looking forward to this conversation. Right. Now, Giuseppe, I know you've been working on graphs for quite some time, and you currently continue to work on graph-based AI systems at your current employer, which is CSI Piemonte, the IT company that serves the government in Italy, correct?
Yeah, exactly. First of all, thank you very much for inviting me to this episode, Vivek. And as you correctly mentioned, I currently work for CSI Piemonte, which is basically a public organization that serves multiple administrations in Italy, providing different types of services and infrastructure, focused obviously on the, digital part, right? And yeah, my personal goal, as you mentioned, I started to work with graphs and knowledge graphs since many years right now. I would say that my first contact with knowledge graphs was in 2010, right? So in 2010, because my master thesis, right, was dedicated to the development of an ontology visualization system. So this was my first experience, and then I continued to work in the knowledge graph world from different perspectives, right? And regarding my experience with CSI Piemonte, my key and personal goal was to incorporate knowledge graph technologies in very established infrastructures and processes, because the CSI Piemonte is a company that is 40 years old, right? So quite old, considering also the last of the companies, especially in the last years. Anyway, so my idea was, okay, if you want to start a project from scratch, maybe the knowledge graph could be an interesting solution, right? Especially now. But what you should do if you want to establish and propose knowledge graph into a very well-established company with a very well-established infrastructure and process.
Thanks for sharing that context, Giuseppe. Is there something in how you think about structuring knowledge now that was influenced from that experience as well?
Yeah. I think that these two experiences are apparently quite different, right? But there are some touching points, I would say, as you mentioned. The problem is that when you work in the journalism field, one of the key goals is taking complex material and making it understandable for people, right? And in this exercise, you have also to identify the key facts, check these facts, contextualize these facts in a specific time span, right? And if you think about the effort that you make when you create a knowledge graph, this is quite similar, right? Because in the knowledge graph, you want to basically incorporate facts related to coming from, for instance, unstructured content, different types of documents, and so on. You have in some way verified this fact, and you have also to contextualize this fact over the time, right? Because one fact could be true, right, in a specific time span, right, but potentially later is not valid yet. So I think that these types of effort are quite similar. So this is why, as I mentioned before, I started my master thesis in a graph project. Then I started this journalism activity, but then I came back to a knowledge graph for these reasons, right? Because I have identified these touching points, and creating these parallel activities was quite exciting for me. But yeah, right now I decided to focus especially on knowledge graphs, right? Because it was quite hard, carry on both the directions.
Perfect. Thanks. Now, Giuseppe, also help us understand a bit more about the current graph-based implementation that you have today, which is actually running in production.
Yeah.
In the in the government context. I do recall that it's a public chatbot in Italy that helps citizens navigate public sector job competitions.
Yeah,
And
exactly.
your knowledge graph sort of sits inside the very pipeline that builds the knowledge base and so on, right? Could you just talk a bit more about that? And why specifically did you choose a graph-based implementation, a graph-based approach in this context?
I mean, it's totally correct what you mentioned. So basically, we developed this chatbot to serve all Italian citizens that are interested in looking for information about public competitions related to job positions in public administrations. And basically, this chatbot actually was quite established in the sense that the development started around 2 years ago. And it basically uses also more traditional technologies, right? In the sense that it has been created on top of storage technologies like SQL and SQL databases, and obviously vector databases like traditional vector databases. So one of the key problems that we had to face for creating the knowledge base of this chatbot was related to the publication of the exam sessions, right? Because when you participate in a public competition, you can usually have to, join or participate in some specific exam sessions that require basically some writing tests or basically conversation tests or other types of tests, right? And what we notice is that this type of information evolves over the time, right? So for instance, in a certain date, the public administration published, for instance, the details related to this exam session, right? But maybe a week later, it publishes an amendment of the information related to this session. So you have to change and update the details, for instance, in terms of calendar time or in terms of place, exam session place, and so on. And this happened many times over the time, right? So in a time frame of 3 months, you have 3-4 changes. Sometimes this exam session was completely canceled, right? And this information was received into a collection of documents. So imagine the situation. You have this set of documents that describe information about the same thing, but there are some, these information are not yet valid potentially, and there are inconsistencies, right, between this information. So if you use traditional technologies like a vector DB in order to store this type of information, you risk hallucinations from the chatbot, right? Because this information is not conceptualized correctly over the time. So the idea was, okay, let's try to model this information into a graph structure, right? In which you have nodes that represent sessions, and you have relationships that describe the evolution between the details related to these sessions. So in this way, we were able to construct a small knowledge base related to these specific details that can help us to create the final level of the knowledge base in a very deterministic way, right? So at the end of the day, the chatbot was able to just retrieve the correct status of the session, right? So in this case, the key thing is, okay, I could not change the entire infrastructure, right? But I would like to bring the value of knowledge graph. So I had to decide a small piece of the entire architecture of the chatbot that could be potentially improved by adding this knowledge graph layer, and it worked, right? So basically, in our ingestion pipeline every day, this information are extracted from the sessions, from the documents detailing the sessions, transformed into the knowledge graph, which is able to understand which is the valid part, so the real valid part of this collection of documents, and put this valid part into the final knowledge base. And that's it, I would say. And the value is, okay, we were able to incorporate knowledge graph into an established architecture and established infrastructure, and we were able to add value just updating a small piece of the entire pipeline that process all this information every day.
Interesting. Now, let's go a step further and try to understand what happens when a specific document gets changed. Let's say there is a change in the exam date. Now, when that change arrives, or which is essentially in form of a document, can you walk us through what the graph actually does with that specific update from the moment it comes, and then how does that flow to the end user who is asking on a chatbot, when is the actual exam date now? Like, what does that look like? Because updation, a lot of people struggle with not just graph creation. What they struggle also with is graph maintenance, pushing updates into the graph.
Yeah.
So how do you think about that in this context?
Yeah, in this context, we decided to keep all the information, so the full flow, right? So let's imagine this is a scenario in which you have the first document that provides details about this exam session. So from this document, we create a node that we call, for instance, session, and we attach to this session all the details, right? All the information in terms of properties of the node. And once a new document arrives, we have to, the first exercise is to understand, okay, this document is related to the previous one. This is quite easy to do, right? Because these documents refer to the same exam session with a specific ID. So it's easy for us to create understanding which was the original document, right? That has been updated by this new version. So we create another session node in which we keep the properties and the details that have not been changed, right? And we just update the property that has been changed. So for instance, let's imagine that the property that should be updated is an updating in the starting time of the exam session. We basically update this property. So we create this node session and we add a next relationship, right, between these nodes. And this is what we do, right? So we continue to add the node in order to track the entire flow, right? So at the end, the final node, the leaf of this, let me say, hierarchy, will contain the correct information, right? But the entire history is stored within the graph. So if there are some issues in terms of chatbot answers, you are able to reconstruct the full story, right, of the evolution of the exam session. But before this approach, we basically fed into the LLMs all this collection of documents, right? So basically, the LLMs had to use its internal reasoning capabilities to understand, okay, this is the final version of the session, which includes all the correct final status, right? But in this way, you are not able to reconstruct the full story of the evolution of the information related to the exam session. While if you create a graph in this way, that could be quite simple in terms of modeling, but in this way, you have a very powerful tool to reconstruct the full story and to understand how the information evolved and potentially why the chatbot failed in answer, right? So the knowledge graph is a tool to, identify the evolution of the information over the time in an explicit way, I would say. Yeah. Yeah, the final user is potentially every citizen in the country, right? In the sense that the main use case of the chatbot is something like, okay, for instance, I have a degree, a master degree in computer engineering, which are I live in Milan, which are potentially the open position from public administration in which I can fit, right? So this could be a potential use case because in the documents related to the public competition, you have all these details, right? It says we are looking for this person as a technical engineer within this administration, and the required qualification is, for instance, a master's degree in computer science and so on. So you can specify in a very easy manner your character, your features, right? In terms of I mean, professional and so on. And then the chatbot provides you all the public competition details related to these open positions. So potentially every citizen in Italy could use this chatbot for this purpose. So for looking for a job in a public administration. Yeah, exactly. It's more a tool for exploring information, right? So not to basically directly apply. So the idea is that I'm looking for for position for computer engineers. The chatbot answers, okay, there is this position, this public competition for instance, in the University of Milan, right? And you can say, okay, I'm interested in it. Can you provide me the date of the exam session or where the session will take in place? And this is a very critical information, right? Because as I mentioned before, this information evolves over the time. So the chatbot should be should be in some way quite sure that the information that provides is correct, right? And the graph plays the role of data quality layer, right? So at the end of the day, in the knowledge base, we just store the final status of the exam session. So in this way, the chatbot should be able to answer with the correct information.
Running, right? You also spoke about this
Yeah.
in the context of the chatbot as well, right? Why exactly is an established institution the hard case when, I mean, technically speaking, they would have more data and more resources and so on? Like, what about that specifically makes it really hard?
Yeah, I mean, because it's not only, I would say, a technological aspect, all right? It's also a social aspect, I would say. So, I mean, sometimes when you have to introduce a new technology into an established company architecture, there is basically a natural effort to maintain the current situation, right? So, and the established technologies and processes and so on, and that's fair, right? It's totally understandable because you are not at the level of a early stage startup, right? In which you can basically explore any technology that is available and you can decide which technology adopt based on your need. Sometimes when you apply some changes from in our established platform or architecture, basically there is a learning curve, right? So people have to start to learn this new technology in some way. And on the other hand, some of the processes, also in terms of modeling the information, should change, right? Because when you have to store data into a relational database, you think in some way, right? When you have to store information into a knowledge graph, you have to think in a completely different way, right? So, for instance, you have to think about problems like definition of entities and the connections between these entities from a semantic perspective, right? Not just from a technical perspective in terms of joins between tables, right? And when you think about in knowledge graphs terms, you have to then understand also about problems like entity resolution. So for instance, let's imagine that you have to store information about people, right? Sometimes from different documents, you have pieces of information about the same person. And when you have to create a database, you probably just store all these single mentions into a new row of the table. But when you have the knowledge graph, you can apply information to say, approaches to say, okay, all these pieces refer to the same person. So you have to identify a way to represent as nodes these single pieces, and as a resolved node, the person, so the real entity in the real world. So I would say that it's a problem, it's a technical problem, because you have to identify a way to integrate a new technology into an existing architecture and platform. But there is also a social and human-driven not problem, but issue, right, that you have to consider. So you have to develop the capability of selling the ideas of this technology, in our case of the graph. And one way to sell this idea is, okay, let's try to identify a small problem that it's quite hard to solve with traditional technologies, like this basically evolution over the time, for instance, of the XM sessions details. And let's try to solve this small problem with this technology, so a graph database, and let's see the results, right? And in this way, you can start to convince people that, okay, this is potentially the way to do, right? But otherwise, if you go to your boss, let me say, and say something, okay, I've seen this technology, knowledge graphs. Knowledge graphs are cool. You can do this and that. And you do not provide information to apply in a concrete use case that involves your company. This technology, it becomes hard, right? It becomes hard to, enable the adoption of this technology within your company. But if you just solve a small problem and you show the value, well, this is at least the first step, right, for integration.
Like, I'm also curious whether you've a lot of times when one is dealing with large enterprise document corpus, right? There are also multiple situations where there are conflicting facts within those documents. Alignment between two documents might not be very explicit. One document might be expected to supersede another document, but some of these relations are not explicitly established. They are well understood when we are reading through these documents, but what's been your experience when dealing with such situations or such scenarios where you have seen conflicting information coming through, right? What supersedes what, and so on and so forth, right? How do you handle some of those situations?
Yeah, I would say that the best solution is to trying incorporate all this conflict information within the knowledge graph, right? So the knowledge graph that comes directly from these documents should in some way reflect this conflict information and make them explicit, right? And obviously this creates maybe a big graph, potentially quite complex, but when you specify entities and relationships and the general information, also conflicting information, exploring this conflicting information within the graph, it's much, much easier than exploring it by just reading documents or by just providing this huge amount of documents to the LLMs, right? Because you make them explicit. And there is obviously another point, right? Maybe using this graph for online services is not the best solution, right? Because this graph is quite complex, it's quite hard. So the idea is that I use this graph just to reconstruct the full story of the information. And then potentially I create a new graph which contains only the final status, the valid status of such information. And this graph could potentially serve online, it could potentially be used for online services, right? So this could be, for instance, a solution. But as I mentioned before, keeping this conflicting information into graph is better than having such information into these into documents, right? Because it is in some way made explicit and allows you also to explore when or why two documents have conflicting information. So this is something that I would adopt, and we will. This is something that we also try to develop. Yeah, it's potentially plausible, and this is also another point in which LLMs come to play, right? Because a collection of contradictions within the graph, it's basically a subgraph, right? So a collection of facts that are in some way connected to each other that provide different information. And putting, for instance, this subgraph as an input to the LLMs to basically identify which is the final, which is the correct version of the detail, the information into this subgraph could be potentially a solution, because you basically save the effort of LLMs from extracting this contradiction from the full set of documents, right? You have just a cleaner artifact that could be potentially processed in a more effective manner from the LLMs. And this could be also a solution to automatize potentially in some way the detection of the correct informations among all these contradictions, because you simplify the work of LLMs, right? I think that one of the key of the most powerful aspect of the knowledge graph is that you simplify the reasoning task of the LLM, right? So you structure the information in a way that the LLM can process easily, that an agent can potentially, because an agent potentially can navigate this graph, can identify contradictory information into within a subgraph and so on. So the idea is, okay, let's create an artifact that is more structured and clear than traditional documents, and let's see how, if the quality of LLMs and agents increases once we provide this artifact, right? I think that this is something that all people that are dedicating their effort into the knowledge graph world are making, right? They want to demonstrate some best practices in improving the value and improving the accuracy of agents and LLMs using the knowledge graph. So this could be some way, as I mentioned, yeah. For, yeah, I think that this true reason, because I think you are talking about two different methods for reasoning, right? In the sense that regarding the LLMs, you have this reasoning, which basically it's very close to pattern recognition, right? There is a very interesting tweet that I read I would say almost 1 year ago from a researcher of DeepMind that said a very advanced pattern matching is indistinguishable from reasoning, right? For human beings. So once you have a very advanced pattern matching, for us it seems okay, the system is reasoning. And this is the inductive reasoning of LLMs. While in the context of graphs, especially knowledge graphs, you have this idea of deductive inference, right? So basically, or deductive reasoning. You have this collection of axioms, you have some rules, And based on the combination of these axiom of rules, you can basically infer new information. And you are able to reconstruct the full process that lead to these results in terms of inference. I think that the two types of reasonings can collaborate in some way, in the sense that they can basically improve themselves by the combination, right, of these two approaches. From my direct experience, the deductive reasoning is hard, right, in the sense that you need a really full control in terms of how you model the knowledge, and but you have also to identify the trade-off in this knowledge modeling, right? Because if your knowledge is really complex, the inference becomes not scalable, right? And on the other hand, if your knowledge is really complex, you risk to identify some issues and contradiction within the knowledge that you created. So as I said before, I mean, there are two ways to reason. One is deductive, the other is inductive. They can collaborate each other. And I think that the trend of neuro-symbolic systems goes into this direction. Right? The idea is, okay, are we able to create an hybrid architecture that is able to leverage both the capabilities in order to bring value? I think that is still an open question, I would say. Yeah, this is something that I'm trying to explore, right? I mean, but I would say that there are a lot of research direction in this sense. So there is no an established way to do these things, right? So it's more a matter of exploring, trying to readapt these approaches to your specific domain, and see how it goes, right? We are still in this type of moment, I would say, in which people start to explore the solutions that are able to combine all these reasoning capabilities. Customer, yeah. Mhm.
Let's say
Yeah, that's an
how
interesting
finance defines
question,
the word customer
actually, that I
might be
encountered many
different
times.
how sales defines
Yeah,
a
from my
customer
personal
or
perspective,
how marketing defines the word
the
customer,
key
for example.
problem
Because
is that in many situations, in many scenarios, you start from the top, right? And you try to define all the possible definition, for instance, of customers based on the different departments and offices that are within a company organization. But I would say that we should start from the bottom, right? So the point is which questions about customer we would be able to answer with the information within our organization. And once you identify these questions that maybe can be different among different departments or offices and so on, you can start to build your, let me say, ontology for basically describing the way in an efficient, describing information in a way that is efficient to answer these questions, right? So I think that this should be the direction, right? Because otherwise you risk to start modeling, and after, I would say, 1 month of modeling effort, you're creating an artifact that is not able to answer questions of your company in a very efficient way. And you have to just identify a lot of workaround, right, to answer the questions. And so the idea is, okay, let's start from the bottom, let's start small, and then let's expand when we need to do it. So let's add complexity to the ontology, add complexity to the semantic layer just when we need it. But let's start from the need of the companies. And so let's not make an academic exercise in which we try to define all the possible definition of customers before looking at your data, looking at your problems, looking at the questions that you want to answer. So yeah, this is my personal suggestion, and this is what I noticed also in my personal experience. Let's start from the questions, then see the data, and then let's start to modeling, right? Yeah, exactly. That's I think that would be the most, I mean, valuable effort in terms of bring values to the company, right?
One topic that I know you've also dealt with, Giuseppe, is the topic of sovereign AI and how that has started to finally be talked about more and more aggressively across EU as well, and most other places, right? Now, I do remember you've done some meaningful work in the healthcare AI space as well, right? In the context of sovereign AI, right, where the
That's
idea, where the core
very
idea is
interesting question, Vivek. Yeah, on the one
in
hand, there
industries
is
like healthcare, where
need of
data should
keep
not
your
even leave the
data into
organization,
your organization,
let alone
right?
the country,
So, for
right?
instance,
With
this
these
is maybe a
constraints,
bit different.
how do
But
how
I mean,
should
for instance, this idea
CTOs,
of using open
CIOs
LLMs, right, could
think
be
about their
one
AI
direction
stack
that you should take into
with these sort of
consideration
constraints? Because it's not just
for
about
managing your
data.
data,
Now it's
right?
also about
Because
how the data
in
gets
very
transformed
critical domains like
into an
healthcare, you
intelligent
cannot
structure, right? Which can be a
send,
knowledge graph,
I
for
mean,
example, or a
your
combination of
data in
knowledge
most of
graph
the
and
cases,
vectors,
for instance, patient data
and so
to
on and so
cloud
forth, right?
solutions, right?
So,
So
how do
you
you
have to
think that
identify some
impacts
strategies to
the
build
architectural
an infrastructure
choices
that is
that
able to serve open
these
LLMs.
uh,
And
CTOs
another
and CIOs?
key point in terms of knowledge management, this is another key problem, right? Because sometimes you cannot move data also within your organization, right? So the data should be basically stay in the legacy database, and you cannot move your data, for instance, in another instance of a database within your organization. So this is a big problem. So in the healthcare exploration that I did, I just to provide some solution to virtualize your data, right? So the key aspect is, okay, maybe I don't want to materialize my data into the knowledge graph because I want to keep my data into the relational databases. But basically, the knowledge graph could in some way provide the semantic structure that potentially can integrate data from your legacy database with data that are, for instance, public and so on. And when you are able to virtualize into the graph the information into your legacy database, then you have access to this data only when you, for instance, make the query, or only when the agents start to explore information to answer a specific question and so on. So in this way, you materialize such private data online, so just when you need it, and you basically are able to create an architecture that preserves data within the legacy database without moving around also in your company, right? Because the access is virtualized, and so you materialize such data only when you need it within the graph. So only when you need to create this explicit connection with other data sources or ontologies and so on. I think that the database solutions like Neo4j, but also other databases are trying to create and provide the features to manage this specific use case, right? Because I think that it's very common in many companies. Yeah, exactly.
No, it does make sense that you don't have to clone everything of your EHR into a graph. A lot of times, just having a simple mapping or a pointer itself will suffice from getting the job done itself. I think Joshua also had a point to add. Got it. Yeah, no, this has been interesting, Giuseppe. Your experience of building some of these production systems, and the fact that you've been able to introduce graphs in existing working operational situations is very, very intriguing. I know we also spoke about that how greenfield projects are potentially much more simpler, much more easier, much more straightforward, right? But as compared to where you have to fit fitting graph-based approaches into an existing system, right, and solve a critical problem, that's where the real challenges come into picture, right? And I think what you spoke about the chatbot for citizens for all their queries regarding specific exams and stuff is a very interesting.
You can follow
seems like
me
a very
basically
simple
on LinkedIn.
implementation
So
gets the
feel
job
free
done, which is
to
obviously the end
ask
goal, right? That
for
people should be able to get
connections,
answer
right?
to their queries
And
in a reliable manner,
if you want to
and that too
basically
from a
enter this
from a
world,
government portal
as I
where
mentioned at the
the
beginning,
liability,
probably
the
I
responsibility is very,
co-author a
very,
book
very, very high.
called Knowledge
I'm
Graphs
assuming,
and
right?
LLMs in
No
Action,
government wants to be, nobody wants to know
which basically we
that the
provide
exam data
different
is passed and they're still.
use cases in which
That
apply
that
knowledge
would be a very
graphs
funny situation.
for modeling
But yeah,
information and also for
very insightful
building
conversation.
agents that are able
I
to
really
leverage
appreciate
such
the
information for
time.
answering complex
Also for our
questions.
audience, just say
And
what's
in
the best
parallel, I
way
recently
they can follow you? How can they
created a
consume more of your
cohort program
content?
called
If you could tell
Knowledge
us
Graph Training
more about that.
Program, and you can find it on the internet at the kg-training.com, right? So if you are potentially interested in a cohort in which we will try to explore knowledge graphs from very different perspectives, maybe this could be interesting for you. And the cohort will start at the end of September. And so you can book a call on the website and we can discuss together to understand what are you looking for, and what are the more details about the curriculum of the cohort. So, these are the ways in which we can stay connected. Okay. Yeah. Thank you so much. It was a pleasure. Bye. Thanks.
Perfect. We'll also add these links in the show notes as well. So yeah, right. But once again, thank you so much for taking the time to say. Really interesting conversation, right? Yeah.